So let's say when you get up in the morning, you want to start your day right, you want to figure out what the right outfit is to set the tone for how the day is going to go, and you've got 2 pairs of pants and 3 shirts that you're thinking about wearing, where presumably you're only going to be wearing one of each because we're in Florida, you don't need to layer up that much unless you really want to, I guess. And for that matter, the assumption here is that you're also going to be wearing one of each because, well, you're not a nudist. Not that I would judge you if you were, but this wouldn't be a very interesting example if you had 0 options because you're not going to wear any clothes. I'm assuming most people like to wear clothes and are going to have to wear clothes and try and make it look good. So, for your 1 pair of pants, you can think of yourself as having 3 options to get from each. That is, from 1 pair of pants, you can wear that with the 1 shirt, the other, or the 3rd. And then for the other pair of pants, you've got the 1st, 2nd, or 3rd shirt as well, for a total of 6 options, as you can see in the tree diagram that is just going above my head, where this line of thinking is something that we used fairly early on in the semester when we were talking about problem solving with some specific examples, and we're seeing it again here because I said we'd be coming back to this, where we're talking about the numbers of ways we can arrange groups of selections, where we have some number of one and some number of another. If you want to get the total number of both, m for the first and n for the second, it's just m times n. In this case, it's 3 times 2 for the 3 shirts and the 2 pants. And to help make sure that we're getting this idea here, at least with our most simple case, let's get one more example for how this can work. Say you go to Chick-fil-A for lunch and want to get a snack from the vending machine. If there are only 4 menu items you like at Chick-fil-A and 16 you might want from the vending machine, where you only have enough money for 1 of each, how many choices of menu item and snack can you get? And yeah, kind of like with the clothes, I'm being a little unrealistic here. I'm being a little bit unfair here in terms of the setup, that probably you wouldn't think get 1 thing from Chick-fil-A and 1 thing from the vending machine. You'd just go to Chick-fil-A, get a sandwich and some fries or a shake or something, and just not worry about the vending machine at all. But we have to think about counting in more broad terms here. So for this, we have to understand is that from Chick-fil-A, we have those 4 options, and from the vending machine, we have those 16 options. So if you want to get the total, you just take 4 times 16, which in this case would give us 64 total options. Pretty easy here. And it's not that much more complicated generally. As we look towards more general cases, we get more towards the idea of this section, the fundamental counting principle, where essentially what we're doing is just taking this and accounting for more groups of options at once. And that's what we're going to be seeing next, is what happens when you go from 2 to 3 and then a little bit further beyond. See you in there.